next important rule is breakpoint. There are two types of breakpoints. One is called a breakaway point, other one is a break-in point. Let us go back to look at the example which we have seen, where my open loop transfer function is k by s into s plus 2. So in this, if you look at the root locus which you have already drawn, look at this. So when k is 0, we know that one pole is at s is equal to 0, the other pole is at s is equal to minus 2. Let us say in this plane that this is s is equal to 0, here I have s is equal to minus 2. Now as the k is increasing, as I said in a root locus, when k is increasing, in the sense you can understand that, so we are giving some energy to these two poles, right? These two poles are open loop poles, but at k is 0, those two poles have become closed loop poles or roots of my characteristic equation. As k is increasing, then those two poles, they have to move, those two roots, they have to move, so they are moving. So how they are moving? One is going, when you look at from the origin, it is coming towards this direction till minus 1, and this is also moving towards the other direction till minus 1. So at s is equal to minus 1, the value k is equal to 1, and at k is 1, both the roots are at same place, they are real and equal, and it is at minus 1. So this point is called a break point. So this is actually breakaway point. So what happened here in this particular example? Now at this point, two root locus branches, they started at different places, they came here, then after this they enter into the complex plane. So once they enter into complex plane, one will go towards either nearest to 0 or infinity. In this particular program there are no zeros, therefore one will go to one asymptote to infinity, the other will go to the another infinity along with the another asymptote. So this is what the break point. So how can you define my breakaway point? Here it is a breakaway point. How can you define my breakaway point? Breakaway point is the point at which two or more root locus branches come and meet and they enter into the complex plane from the real axis. So your breakaway point is like it's a gateway. It's a gateway for the root locus branches. If you want to, let us say my root locus is on the real axis, then if you want to jump into the complex plane, you need a breakpoint, right? You cannot jump from the real axis to the complex plane until otherwise if you don't have any breakaway point. So breakaway point is the gateway to enter from the real axis to the complex plane. This is what the breakaway point. Now what are the different possibilities of breakaway point? So we have breakaway point possibility. Let us look at this particular example. So in this take I am taking only two poles. So if you take two poles and you can see that in between two poles we have root locus area. So whenever two open loop poles are adjacently placed and in between if you have root locus area, yes, there exists one breakaway point, because these two will come towards here, then jump into the complex plane. Second possibility is, if at all if you have two poles and those two poles at one point like a double pole, so double pole, and either side if you don't have any root locus area. You know what do you mean by root locus area? So you can say that if any point lies in the root locus area, that from that point you can count the number of poles and zeros right to that point, and if the number is odd, then that you will have the root locus area. If the number is even, you don't have any root locus area. Now sometimes there will be a situation where you have two poles at one point, double pole, and either side of you don't have any root locus area, and that point itself is the breakaway point, because they can jump into the complex plane from that point. And these two are for the real axis, but in some cases there can be a break point in the complex plane. For example, I have four poles at origin. Here I have minus 2 and at minus 4 plus j4 and minus j4. So in this example So there can be complex pole here, that means from middle of this to this, that means you have from -2 to the complex pole, in between you can have one breakpoint, and here also I have another breakpoint. So complex breakpoints also possible for complex systems, but for simple systems you will have breakpoint always on the real axis. Now this is what the breakpoint is. So what is a breakpoint? I can say the breakpoint is a point at which two or more root locus branches will come and meet, enter into the complex plane. It is a break away. Next, break in point. So break in point is, we can define it as, it is a point at which two or more root locus branches will come from the complex plane and they enter into the real axis at the break-in point. So at this point they come from the complex plane, they enter into the real axis. So what are the different possibilities of break-in point? Now if you have two zeros adjacently placed, in between, if you have root locus area, there exists one break-in point. So two zeros are there, in between I have root locus area, so in between there exists one break-in point. So what does it mean? If you have two zeros, we know the zero is the terminating point of one of the root locus branch. If a two zeros are, means two root locus branches should terminate at this open loop zeros. So they are coming from somewhere, they are in complex plane, they enter into the real axis at break-in point. This is one possibility where break-in point can exist. Now similarly, if you have two zeros at one point, it's like a double zero, and either side of the double zero, if you don't have any root locus area, then that point itself is a break-in point. Similarly, so if you look at all poles and zeros on S plane, if the rightmost side, if you have 0, so complete negative real axis if you have 0, and again from 0 to minus infinity if you have root locus area, then there is a possibility of break-in point, right? So 0 must be towards the most negative, and after that you need to have the root locus area. So there is a possibility of break-in point. So these are the situations where we can get break-in and break-away points. Now, so what is the procedure to calculate those points? So as per the calculation, there is no difference between break-in and break-point. Therefore, we generally call it as a break-point. Now we will see how to calculate break-in and break-away points. So as per the calculation, there is no difference between break-in and breakaway point. Both are generally called as a break point. So what is the procedure to find break points? Now look at the first step. In the first step, we have already open loop transfer function. Therefore, write the characteristic equation 1 plus gh of s is equal to 0. In second step, rewrite the equation in the form of k is equal to f of s. Because already we have gh of s. In gh of s there is a variable k. So how I am writing this? 1 plus gh of s is equal to 0, k is equal to f of s function. Third step is find the roots of dk by ds is equal to 0. The first derivative of the equation k is equal to f of s, and equate it to 0, and find the roots of this equation. So these roots, the roots of dk by ds is equal to 0 will have both valid and invalid breakpoints. It is not that all the roots of dk by ds is equal to 0 or breakpoints. So you may have valid breakpoints or invalid breakpoints, combination of valid and invalid breakpoints. Then how to know whether they are valid or invalid? So if the breakpoints are real points, only real points, then it is very easy. So if the breakpoints are real points, locate the points in S-plane and see that that point is there on the root locus area or not. For any given problem, so first of all we will take poles and zeros, we identify the area of the root locus on the real axis. Now take this point, locate in that S-plane, see that whether it is fitting into the root locus area or not. So if it is not in the root locus area, then it is not valid. You can call it as an invalid breakpoint. If the point is there in the root locus area, then the particular point is called valid breakpoint, because breakpoint is a part of the root locus. Therefore, whatever the roots you are getting, so s is equal to something, that point should be there in the root locus area to have the valid breakpoint. But sometimes I said there are complex breakpoints also. If the roots are complex, and take that complex value, substitute in the equation k is equal to f of s and find out the k value. If the k value is real and positive, that particular complex point, s is equal to something complex point, is also a valid breakpoint. For complex systems, I said if you have 4 poles, one is at 0, other one is at minus 4. So if you have plus j4 minus j4, so like this, if you have 4 poles, there is a possibility of having complex breakpoint. So whenever you get root dk by ds is equal to 0 is a complex, substitute k is equal to f of s function and try to look at the what is the value of the k. So if k is real and positive, that complex point itself is valid breakpoint, otherwise it is invalid breakpoints. And these complex points are always in pair. Therefore, if you substitute one complex point, that is enough. The other one is automatically, if the first one is valid, other one is valid. If the first one is invalid, other one is also invalid.